All right, you do not need $1,000 multimeter in order to work in the automatic gate access control, video surveillance, and low voltage business. All right, you just need a multimeter that has some specific features, but that's not what this video is about. What this video is about is solar panels, batteries, and your mains power from a branch circuit. They're all tested differently. Okay, so quickly, let's talk about solar panels. Solar panels, if you have a solar panel that's matched to the system, I don't care about voltage. I don't care about voltage. You cannot have current without volts. You can't have amps without volts. All right, which breaks down one of the other myths too of it's not the volts, it's the amps that'll kill you. Bullshit. You cannot have amps. You can't create amps out of thin air. Without voltage, the potential, you cannot have any work to be done, which is the amps. So what we care about in a solar panel is the short circuit current. So think about that, short circuit. Anytime that we short circuit a battery, we're going to kill the battery. Anytime that we short circuit mains, we're probably going to solder the two, we're going to weld the two wires together or damage them, and then we're going to probably trip the breaker. Not always, depending upon the circuit, but keep that in mind. We test those three things differently. So at any point in time, current as in a battery as well as mains is important as well too, but in a solar panel that's matched correctly, all I care about is short circuit current. And I go through this day after day after day where I get the question of, well, my voltage is good on my solar panel. It does not matter. If it's matched properly, it does not matter. I'm not saying don't test volts, but what I am saying is when I look at the back of the solar panel to see what the short circuit current is, and I look at the back of it and see that the open voltage is whatever, let's say 18 volts for a US automatic system or 24 volts for a camera or an access control system, and I look and it's rated at 28 volts for a 24 volt system, I don't care about what the voltage is. I don't give a shit about it. It does not fucking matter. All that matters is the short circuit current. You cannot have amps without volts. It just doesn't happen. They're characteristics of the circuit. It's nothing magical. It's the reason why I stay away when teaching these things, to stay away from Ohm's law and Faraday's law and all this other shit that has to do with circuits on paper, but in the real world, all I care about is those two things, what's your volts and what's your current. And if you knew Ohm's law, then that would mathematically, you would easily be able to figure out your resistance, but we don't care what that is. There's a reason why on most of the shit that we have doesn't say what the resistance is. It's that characteristic is not important. We just want to know, is the volts putting out the volts that it says that it's supposed to have, or is being supplied to the device under test, and is the current below what the current rating is? That's all that we care about. We don't care about mathematically what it is. We are in a replace society, not repair society. So you need to know how to test these things differently. Solar panels, you want to test the short circuit current. That is the main thing. Also creates another myth that gets busted. It's not the volts of the amps that'll kill you. The characteristics of volts is the only way that you can get possibly amps. You have to have voltage in order to be able to do any work. The potential has to be there for the actual work to be done. So that's why that myth gets busted easily every day. Now, with that in mind, batteries, if I had took a 12 volt power supply, hooked it up to a piece of music equipment, and it was putting out 12 volts, we would go, okay, great, that's great. That's all that it needs. That's what the power supply says it has. That's what the device under test says it's supposed to have. We're good to go. If you take a battery that is a 12 volt battery and you test 12 volts, you have a dead battery. God forbid you're testing it like that without a load on it, which is all that matters. You definitely got a dead battery, because as soon as you load that battery, that voltage is going to shoot through the floor. Now, we've all experienced a dead battery in our car, and when we probably go to test it, it actually has 12 volts and it'll probably still start the car. There's a lot of things that are going on. We're dropping the voltage and we're kicking that current way up. So we have the ability in some circumstances to still power the device under test. But in gate operators, we've got a lot of funky things going on when we start dealing with electronics that we also have to make sure that we don't have any significant voltage drops in as well. So most of the time we have a battery system that's created that will handle all those voltage drops in a normal situation, but we still need to make sure that we're testing batteries different than we test a branch circuit or solar panels. So if you test a battery, a 12-volt battery at 12.5 volts without a load, you have a battery that's at 50% capacity. If you test a 12-volt battery at 12 volts, you have a dead battery. There is just no ways around it. That is the way batteries work. Now, there's a chart that you can just look up online and see what it actually is, but just take old Uncle Mike's word for it. If you're at 12.2, dead battery, 12.3, 25%, 12.4, 25%, 12.5, you're at probably 50%, and then it goes up there to about 12.8 is what we want to see. 12.8, 12.9 standing voltage for a battery. That's kind of what we want to see. And we want to charge a sealed lead acid battery or AGM battery at about 13.8 to 14.3 volts. And it depends on, some chargers do some smart stuff. So you actually might even see a voltage spike of like 90 volts if your meter's fast enough and you're paying attention or you're monitoring it while that's actually doing that. And not getting into any details, but those voltage spikes help break the sulfation that's on the plates, break it up. So getting past all of that, now we've established that testing a solar panel and testing a damn storage device, which is what a battery is. Batteries don't create power, they only store power. Solar panel creates power. All right, takes the sun, converts it, does magic shit in the solar panel, and then puts it out on the cable. That creates power. And then, if you will, it's fair to say that the service coming out of the wall or serving coming to a branch power, that's actually creating power too. Somewhere, 100 miles away in a coal plant or a nuclear plant or something like that, or hydroelectric plant or something like that, it's creating power and it's being transferred, if you will. That's really, in essence, it's a power creation device as well too, because it always has power. It's not just storing it, but it kind of is storing as well too. All the power is not being used all the time out of the main circuit. But now we're getting out of my scope of what this video is and my technical capability. So now when we test mains, we got another weird thing going on. When we test mains, we need to be at what that voltage is supposed to be coming out of that panel at our circuit. That's it. No ifs, no ands, or buts. If it varies from 3, 4, 5%, we got big problems. Had to deal with this the other day, and it was funny. Nobody actually got it. A room full of technicians, nobody wanted to actually hear it. When you walk up to a circuit, 120 volt circuit, and you see that it's 110 volts without a load or even with a load, you have big freaking problems. Stop what the F you're doing and figure out what's going on. It could be just like women. This thing is lying to you. I said that the other day in class and there was full of women. So it was funny then, and hopefully it's funny now as well too. But anyways, multimeter, and if you are a woman, you could just say the same thing about it as a man. This thing, just like men, will lie to you, okay? This thing has the ability to lie to you. And this $1,000 meter doesn't have a feature that my $300 meter has that will figure out what that freaking lie is. And the lie is that this will tell you that there's voltage there when there is no voltage there. All right, there's different types of ways that can happen, but what I'm referring to is what's called capacitance voltage, or in marketing terms, ghost voltage. But basically it's two conductors, one energized, one de-energized. The one with the energized, that has the magnetic field, transfers the magnetic field to the one that's de-energized and tricks this thing to think that there's power there. And you can set it on a feature that will actually load the circuit, right? So in essence, try to pull some electricity from it and then realize that it's actually not there. This meter doesn't even actually have that. It has some other stuff for the electronics world, but we deal with electronics, electrical, and so on. So this doesn't have that feature. So anyways, long and short of it is, testing mains is tested a different way as well too. You basically, in essence, have endless current out of that breaker panel for what we would do, but it's limited by that breaker. So when you start to see voltage drop out of that, we have big freaking problems, especially when the circuit's not loaded. If you see 110 volts, stop what the F you're doing trying to diagnose the device under test, because guess what? The device under test ain't gonna work because you don't have good power. Now, it could be said, and I haven't seen this, that there is a breaker panel or a circuit coming from the service side that is 110 volts. The same thing applies. If you see an increase or decrease below 55%, below 5%, you have a problem because there's endless power sitting there. You're talking about a 600 amp circuit, a 240 volt circuit that's coming off of that breaker panel that's split in the middle to get your 120 volts off of one side. That right there has endless current for what we would do. We're talking about drawing 6 amps. This thing will put out 200 amps. Now, again, we're limited by that, by what the breaker is. So the breaker's going to trip. But if we see that voltage come down like that without a load, or it wouldn't come down and you would just be testing it without a load, you have a problem. If you test it with the load, you have a problem, but the problem is not to the circuit panel. The problem could very well be at the circuit panel or in between there, whatever the branch circuit, however it's run, or the device under test. So what you have learned today in this 11-minute video, and I never can make them short, I've been trying. What you've learned today is those 3 things are different things. The solar panel, the battery, and main service. Solar panels creating power, okay? Very, 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 very inefficiently. Probably about 10 to 20% efficiency. Maybe in a solar panel that's thousands of dollars, maybe a little bit of increase in there. But we don't care about voltage. We want to test the short circuit current. We want to see what work is able to be done. And you're doing that without it loaded. And there's tricks in here that you need to know before you go start testing that. You need to learn how to test short circuit current. You should already know how to test current on a device, either with your clamp meter or through your multimeter. Clamp meter makes it safer, and I always say buy a multimeter and a clamp meter because sometimes you need to test current and voltage at the same time. There are some meters that will do that, but you don't want one of those. You just want to get you a $300 meter and a $300 clamp meter that tests DC and test it. Now, the problem with the clamp meter on those circuits for solar panels is sometimes they're not sensitive enough to be able to pick up those lower current. So we need to make sure that we have this, and because it's an amp, 2 amps, 3 amps at 12 volts, even 100 amps, even 1,000 amps. I do this in class all the time. Again, going back to it's not the volts, it's the amps that'll kill you. I say, how much will this battery, big 35 amp hour battery, how much current will this put out? And everybody's like, oh, 700 amps, 800 amps. Okay, so it's the amps that'll kill you, and it only takes 250 milliamps to kill you, and you're telling me this thing's to put out 1,000 times that, and then you grab positive and negative, and you realize that I don't die, even though that would probably be fun for some of you guys. Anyways, you put your hands on positive and negative, and you don't die because the voltage can't penetrate your skin because your skin is a variable resistor. I've heard 1,000 ohms is what your skin is, but as you go up in voltage, it will penetrate your skin, if you will, 80, 90 DC and 100 volts AC or whatever the case may be. But you have to understand that in the short circuit current and those lower currents, to test it with this just by grabbing it with your hand, no big deal. But at 120 volts with 1 amp of current, you're going to get the hell shocked out of you. And on top of that, I just told you I have unlimited current out there, limited to what the breaker is, and you're going to get zapped pretty freaking good. And it doesn't take much voltage and very, very little current for you to feel that. So short circuit current on the battery and on the mains incoming power, we would not test that because then we're going to trip the breaker. So that solar panel is a voltage creation device. You need to know how to test short circuit current. Batteries, you need a battery tester, and you need to know how to test it with a load and without a load, and also test your charger as well too, which is something I need to start talking about, because you have to have a solar to charger to battery match in those cases. So I need to start talking about how to test chargers as well too, but we'll get past that. It's something I just thought about. And then main service. If you get 120 volt out that panel, and then you go over to your branch circuit and it's 110 volts, you have a problem. Stop what the fuck you're doing, because it might not be in the device under test. It might just be in that circuit. And most of the time, it's a flaw in the wire or something along those lines. It's not in the panel itself, although that does happen. But you'll see all the circuits being affected by that, not just this one circuit. So, boys and girls, remember, this is your friend. and it will lie to you. It's the second most important test device that you have in your electronic test device that you have in your arsenal. But you have to know how to use it. If you don't know what these holes on the bottom do, or all of these switches do, and all of these soft buttons do, you need to make sure that you know, because there just could be one thing, for instance, testing solar panels, that could screw you up and cost you hundreds and hundreds of dollars if you don't know how to use it. You could test how long wire is. You could test what the resistance of the wire is so that you know what the power is going to be on the other side, and all kinds of things. But those are the three things that we got to keep in mind, that when we're out there testing panels, batteries, and service is tested three different ways. So you have to be cautious when you're using your multimeter to test it. And now you can go sell some gates.